We've talked about a number of the different types of radiation that will come in and get us, and some of the ways that our atmosphere is protecting us from those. But there's one other thing that's going to be coming from the sun that we want to address, and that's going to be these solar flares. Now, these solar flares are the result of electrical storms on the surface of the sun. So we have our sun here, and even the curve here is not even quite in relationship to our Earth there, but on the surface of the sun, there's periodic electromagnetic storms. And these electromagnetic storms create sunspots. Their locations on the surface of the Earth, they're darker than the surface of the sun. They're darker than surrounding areas, and these guys can be bigger than Earth itself. Gigantic electromagnetic storms, and these storms are spewing out electrically charged particles. They send out these electrically charged particles, which we call plasma. Okay, now, here we are, our innocent little Earth, and we have plasma coming to us from the sun. Okay, now, what does the Earth have in defense? All right, well, there's a few things that the Earth has going for it. First off, we rotate, and as we rotate, there's going to be the core, the mantle, and the crust of the Earth. Well, inside the Earth, there is the inner core and the outer core. We'll learn about these later in the semester, but one is made out of solid iron, one's made out of liquid iron, and they do not travel at the same speed. Okay? One is actually going to be spinning faster than the other. And as they're rotating, as one is going a little bit faster than the other, it creates a magnetic force field. Now, I know this is sounding rather scientific-y, and it sure is, and that's what's so exciting about it. We call this magnetic force field the magnetosphere. And the magnetosphere, as exciting as it sounds, kind of sits here like almost like a donut. Right? And so it's going to be kind of around there and around there. And if we could just picture this whole round magnetic force field that's keeping our Earth safe. Now, most of us live at our mid-latitude, so we're going to be all right. But as these electrically charged particles are coming in, they're deflected towards the poles. And then they start to come in, and as they come into the upper part of the atmosphere in these polar regions, there's less people, there's less plants to get damaged by them, but a lot of that energy is also absorbed. As that energy is radiated off, it releases light energy. Okay. Now, what do we see that's light energy towards our polar regions up in the atmosphere? That's going to be our northern or southern lights. We also call these guys auroras. Like Aurora Borealis. Aurora Borealis just means that it's in the north. Aurora Australis is going to be those southern lights. Okay, so quick review. Sunstorms, electromagnetic, bigger than Earth, darker than the surface of the sun, spewing out plasma. That plasma comes towards Earth, and plasma for you and me is really, really bad. So, but fortunately, we've got this magnetic force field going around from the inner core and the outer core, not spinning at the same speed. That magnetic force field, known as the magnetosphere, deflects the plasma to the north, to the south. As it does finally come down into our atmosphere, that energy, the plasma, is absorbed, releases light energy, which we know and love as our northern and our southern lights.